In this video, we're going to look at polynomial division using boxes or the grid method. So for starters, let's go back and review multiplication using the grid method. The grid method is a tool used to help students understand multiplication. We use it to aid us in understanding the multiplication and division of polynomials. It works because of the relationship between multiplication and area. So just a quick back to the past, when we were little, we used little boxes and we said 3 times 7 was 21. And that was showing us if we had a box that was 3 inches by 7 inches and we multiplied it together, the area was 21 square inches. So the factors were on the outside of the box and the product was the area or the inside of the box. So in example 1, we're supposed to multiply these two trinomials together. When we do multiplication using boxes, we put each of those trinomials on the outside of the box. Those are the factors. And then for each term, we need a separate row or column. So that would mean we need 3 rows and 3 columns. Then we pair together each of these terms to get the product on the inside. So for the first term, we do 2x squared times 3x squared. 2 times 3 is 6, and x squared times x squared is x to the 4th, so we write 6x to the 4th in the box. For the next term, we're going to do 2x squared times 2x, which when we multiply those together, 2 times 2 is 4, x squared times x is x cubed, so we have 4x cubed in the box. I usually write plus 4x cubed to show that it was a positive. So we continue this process and we fill in each of the rest of the boxes. We should be pretty comfortable with doing this by now. Then we need to go through and combine like terms. Remember, things with the same number of x's can be put together. So I have 6x to the 4th in the first box, so that's going to come down here, 6x to the 4th. I have 2 boxes that have x cubes in them. So I have 4x cubes and negative 3x cubes together make positive 1x cubed. For x squareds, I have 3 boxes that have x squareds in them. I have 6x squareds minus 2x squareds minus 2x squareds is a total of positive 2x squareds. For the x's, I have a 4x and an x. When I put them together, that equals 5x. And then down there on the end, I have a negative 2. So that's my last term. And this is the product, whereas the terms on the outsides were the factors. Pause the video while you try to do the multiplication of 3x minus 1 times the quantity 5x squared minus 3x plus 2. Draw the boxes and see what you get. So I had the factors on the outside in blue and I filled the product in green on the inside. And my last step is to just write down the final version of this product. I had 15x cubed, then I had 2 terms with x squareds in them to combine to 14x squared. I had 2 terms with x's in them to combine to positive 9x, and then I had the minus 2 that was on the end for the constant term. I want to be sure we realize that these diagonals were where our like terms occurred that we put together to get each of these middle terms. Okay, let's turn the page over. In this page, we're going to do a division. Division and multiplication are inverse relationships. So we want to take this cubic on the top and divide it by x plus 3. On this piece of paper, there's detailed explanations of the words that I'm going to be saying. To make it a little easier for you to follow, I'm just going to jump to a blank piece of paper here. And you can watch. If at the end you want to go back and write things down, you can, but they're already written down for you step by step. So for this one, I start out, and what I have on top here is what I'm dividing. So that means this is really the product if I were multiplying. Remember back we had that little example of 3 times 7 was 21? where the 3 and the 7 were outside the box and 21 was inside the box. Multiplication and division have an inverse relationship. So 21 is the product, means that 21 divided by 3 is also 7. If you take the product and divide by one of the factors, you'll get the other factor. So that's what we're going to do. That was a product. Down here on the bottom, this is a factor. When we divide those two, the answer is the other factor. All right, so x plus 3 is a factor, so that's going to go outside the box. I don't know how many boxes to make, so I'm just making a never-ending box that has 2 rows in it because I have an x and a plus 3 that I'm dividing by. So the product was this cubic. The product is what went inside the boxes. So the first thing that I need to realize is I have to have x cubed inside the boxes. So I'm going to start out and I'm going to write down x cubed. Well, just like we did when we were factoring, if there's an x cubed there, I can figure out what must go on top here so that when I take x times this number, it gives me the product of x cubed. That means the number that's on top must be an x squared, because x times x squared is x cubed. Then, once I know the top number is an x squared, I can take the x squared times positive 3 to get the product, or the area of this box, and I can fill in a 3x squared. Now we need to work on the second column. You remember when we were multiplying that these two terms went together to give us our total number of x squareds. What we have up here in the original problem is 2x squareds. So I need the sum of this whole circle here to be a positive 2x squared. If I have 3x squared now, what do I need to put in this missing spot so that I have a total of 2x squared? I need negative 1x squared so that when I put my two groups together, I have positive 2x squared. Once I have negative 1x squared in that box, I can then figure out what must have gone up here in the spot above it so that what times x gives me negative x squared. Well, I need a negative 1x, or I could just write negative x. Once I have the top of the column, I can then multiply to find the product. I have a positive 3 times a negative x would give me negative 3x, and that's what gets filled in the bottom box. Now I need to figure out what goes in the third column. Remember that these two would be put together to give us our total number of x's. In the original problem, I have minus 5 x's. If I have minus 3x's already in the box, then I must put a minus 2x also in the box to have a total of minus 5x. Once I know what's in the box, I can work backwards to figure out what number goes in the top of the column. I know that I would have multiplied x times the number on the top to get negative 2x. So on the top, I must have a minus 2. Now that I know the factors on the outside of the box, I can get the number in the bottom box because positive 3 times negative 2 is negative 6, and that is what must be in my bottom box now. Now I look back to my problem. What was I supposed to have as the constant term? In the original problem, the constant term was minus 6. That's what I have in the box, so this was an even division. There's no remainder for this problem. Later we'll do some problems that do have a remainder, but this tells me a couple things. It tells me that x plus 3 went in evenly, which means x plus 3 is a factor of this cubic, and it also tells me that I have another factor that's right up here on the top, which is the answer to the division. That's x squared minus 1x minus 2. This is a factor, and it's also the answer to the division. If you feel like you've got it, You can pause the video while you try in example number 4, or I can walk you through the steps of example 4, and then you could try the next one on your own. Okay, whichever method you choose, to either pause now and then check back, or watch this from the start. We start out, what we're dividing by is x plus 2, so that's going outside on the edge of the box. Because there's 2 terms in what we're dividing by, I know I'm going to have 2 rows in my box table here. Next, I have the top. This has to be inside the boxes because that's the product or the area. So I know I need to have x to the 4th in the box. So I'm going to start out and I'm going to write x to the 4th in the box. Next, I'll figure out what goes on top. I know what goes on top because whatever I'm putting on top had to multiply by x to get x to the 4th. So this must have been an x cubed, so that x times x cubed would give me my x to the 4th. Now that I know the 2 outsides, I can figure out what goes in the bottom here, because I need to do positive 2 times positive x cubed is positive 2x cubed, and that's going in the bottom of the box there. Now I'll move on to the second column. In order to figure out what goes in the second column, I need to realize these 2 things would have been x cubes. Those 2 terms are x cubed, and when I put them together, I have to have 4x cubed, because that's how many x cubes I had in the original product. So if I already have 2x cubed, my missing amount is the other 2x cubed. Now that I know that, I can figure out what must go on the top, because the number on the top times x has to make a product of 2x cubed. So what times x gives me 2x cubed? I need a positive 2, and I need x squared, because x squared times x is x cubed. Now I can determine what goes in the bottom by taking the product of positive 2 and positive 2x squared multiplied together is 4x squared. Next, I'm going to determine what goes at the top of the next column. Remembering that my x squareds get grouped together, I have to have a total of minus 6x squared. If I have positive 4x squared, I'm going to need negative 10x squared, so that when I combine the terms, I have a negative 6x squared. Now that I know what's inside, I can figure out the outside, because x times what goes up here has to equal negative 10x squared, so I must have a negative 10x up on the top. To find the bottom box, I do a negative 10x times a positive 2 is a negative 20x. I'm going to have to continue my rows here a little longer because I'm not done yet. I know I'm not done yet because what I have down here still has x's in it. I haven't found everything in my quotient up there. Okay, so I have a negative 20x, but I'm supposed to have a minus 15x. So that must mean I have positive 5x's that need to go in the box here. So what goes on top? What times x gives me 5x? Well, that's a positive 5. Then to figure out the bottom column, I do plus 2 times plus 5 is plus 10. Now I'm down to a constant, so I should be done. But looking up at the original problem, what am I supposed to have as my constant? I'm supposed to have a negative 8. That means that I must have had something floating out here that was a constant that's left over on the end. So positive 10 plus what equals negative 8? Well, that would be negative 18. If I try and work backwards, now that I have another column thrown on the end here, I would be saying what goes on top so that when I multiply it by x, it gives me negative 18. Well, I know I can't do that, which means my negative 18 is really the remainder. And what's going to go up here is a negative 18, and that's going to be over x plus 2. So it's over what I was dividing by in the original problem. I can either write that as subtract 18 over x plus 2, or I could write it as a plus a negative 18 over x plus 2. So again, my final answer for this one is x cubed plus 2x squared minus 10x plus 5. All of that is minus 18 over x plus 2. By the way, in some contexts, they will write this as r negative 18 for remainder of negative 18. I prefer the fraction method better, but the negative 18 is technically the remainder. Okay, here's example 5, which was the bottom of that last page. In this one, I'm taking 2x cubed plus 6x minus 25, and I'm dividing by 2x minus 4. So what I'm dividing by, 2x minus 4, is going to go out in front of the boxes right here. On this worksheet, they made the correct number of boxes. Again, if I were doing this, I probably would have just left this long open trail of boxes, and I just keep going until I get down and I don't have any x's anymore. So I start out, and I fill in the first box. I know that this has got to be the inside. The top of my division problem has got to be the inside of the boxes, so I'm going to put 2x cubed up here. So what must have been on top? That must have been a positive x squared. Then I take my x squared times negative 4 to get negative 4x squared. And I can double check down here that that's worked. Next thing I realize is whatever goes in this second box has to be looped together with my negative 4x squared to get what? Oh, look back at the original problem here. I don't have any x squareds, so I have to get 0 x squareds. If I have negative 4x squared, I must be putting down a positive 4x squared to get 0 x squareds. So if I have a positive 4x squared there, what must have been on the top? This must have been a plus 2x. And then if I do plus 2x times negative 4 in the bottom box down here, I have a minus 8x. If I look over here in the next part of my problem, I can see that those matched up. Now I'm trying to figure out what goes in the top of the next column. So what goes in this box right here? Well, I know that I must put that box together with a negative 8x to get a positive 6x from the original problem. So that means I need to have plus 14x. So if that's plus 14x, on the end here I must have plus 7. And then in my final box, I have 7 times negative 4 is negative 28. I go back and I check my original problem. I was supposed to have a minus 25 as my constant term in my original problem. So when I'm trying to figure out what's going to go out here, is there any remainder? These two together have to equal a total of negative 25. So that must mean I have plus 3 floating out there. Plus 3 is my remainder. So when I go to write my final answer, I have the numbers on the top, which is x squared plus 2x plus 7. Then I have my remainder, which gets written on the top of a fraction of what I divided by going underneath it. And there's my problem. You can pause the video while you try the next example. This one, I have a great big polynomial on top, x to the 5th. So that tells me I'm going to have a long row of boxes here. What I'm dividing by is an x minus 6, so that's going to go out here on the side, x minus 6. Then I start out with my first term. 2x to the 5th has to be inside the box, so I put 2x to the 5th inside the box. Now I can determine what's outside on the top must have been a 2x to the 4th, because 2x to the 4th times x is 2x to the 5th. Then I can figure out the product on the bottom by doing 2x to the 4th times negative 6 is negative 12x to the 4th. I know that these two terms would have been grouped together to get my total of negative 11x to the 4th in the original problem. So that means I need to put plus 1x to the 4th in the box. Now I can figure out what goes on top by saying what times x gives me 1x to the 4th. That would be a positive 1x to the 3rd. I don't have to write the 1 if I don't want to. Then I can find the product for the bottom box, 1x to the 3rd times negative 6 is minus 6x to the 3rd. I know that these two boxes are going to be looped together to give me my total of negative 11x to the third. That means I need another negative 5x to the third to get to my total of negative 11x to the third. Now I can figure out what goes on top because I multiplied x times this number on top to get negative 5x cubed. So I must have negative 5x squared times x to give me negative 5x cubed. I can multiply to get the product for the bottom box here. Negative 5x squared times negative 6 is positive 30x squared. These two boxes would have grouped together to give me the total of x squareds. I have 31 x squareds in the original problem, so that means I'm missing one of the x squareds. I just keep drawing more lines to add on boxes until I run out of x's. If I have plus 1x squared in the box, on the top I must have had plus 1x because plus 1x times x is 1x squared. Then I can find the product on the bottom by doing plus 1x times minus 6 is minus 6x. I know these two terms must be grouped together to get a total of negative 11x. If I have negative 6x, I need another negative 5x to have a total of negative 11x. So what number went on top is a negative 5, so negative 5 times x is negative 5x. And then to fill in the bottom, negative 5 times negative 6 is positive 30. Again, I'm just going to keep making these boxes longer if I need to. I'm down to a constant now, so my constant in the end of my original problem here was a positive 32. So that means looping these two together, I need another plus 2 out here. If I try to figure out what goes up here in the top of the column, what times x gives me positive 2? Well, that's not going to work out because what I have left here is my remainder. So the way I'm going to write it is I'm going to start out with my original polynomial. I'm going to write the whole thing down here. My answer to the division is 2x to the fourth plus x to the third minus 5x squared plus x minus 5, and then I have my remainder. It's positive, so I'm going to put a plus. My remainder was 2, and I'm going to write that 2 over the x minus 6, which was what I was dividing by in the original problem. And this is the answer to my division. You can pause the video while you do the final you try. The answer was down here on the bottom of the page, 3x squared minus 5x plus 4. There was no remainder. If you got that, good job. If not, let's look while we go through the steps here. So, for starters on this, we had 9x cubed minus 13x plus 20. That's going to have to be inside the boxes. We were dividing by 3x plus 5. That's going to be one of the factors. So I'm going to write that out in front here, 3x plus 5. Just make my long string of boxes here, and then I'm going to start filling in. I know I start by putting the 9x cubed inside the first box. If I have a 9x cubed inside the box, what must have been on the top so that when I multiplied, I got 9x cubed? Well, 3 times 3 is 9. And x squared times x is x cubed, so I have a 3x squared up there on top. I can find the number in the bottom of the column by multiplying 3x squared and positive 5, which is plus 15x squared. Remember that these two terms get looped together to figure out how many x squareds I have. Well, in the original problem, I don't have any x squareds. I have 0 x squareds. If I've got plus 15x squareds in my product right now, I'm going to have to put minus 15x squareds in there to balance out to 0. So what must have been on top? I must have had a minus 5 and an x to put them together to get minus 15x squared. To fill in the product on the bottom, minus 5x times plus 5 is minus 25x. To get the next part of the inside, I know I have to have a total of minus 13x for my original problem. I currently have minus 25x, so that means I'm going to put plus 12x in the box to make a sum of minus 13x. So what must have been on top? It must have been positive, a 4, and I don't need another x. So let me erase that. I just have plus 4. By the way, a good check while you're doing this is usually the terms in the top here, they go down by 1 each time. So I've got x squared, then I've got x, then I have no x's. Anything left has got to be a remainder once I've already used all my x's. So that's a good check in case you're making a mistake like I just did right there. All right, so I need to fill in the bottom column. So I have 4 times 5 is positive 20. And I want to check back to my original problem because I know that these guys are going to loop together to make my constant term. Well, my constant term was plus 20 in my original problem, so there's no remainder. There's nothing that needs to go out here. And I'm done. This is the answer, the quotient. So I have 3x squared minus 5x plus 4. Hopefully you'll see that what we have coming up is linking this to factoring. If I had asked you to factor 9x cubed minus 13x squared plus 20, which was the original problem, if I asked you to factor that right now, you have no idea how to factor that. You could do it if this were squared, but you don't know how to do that when this is cubed. But we've just shown by division that 3x plus 5 times 3x squared minus 5x plus 4 is equal to the original problem. So there's your first step in factoring, and you can go through and factor this cube by doing a division and getting two smaller things. If I want to factor it completely, I would need to check, can I factor this quadratic on the end here? To check for that, I'm looking to see, are there two things that multiply to 12x squared and add to negative 5x? Well, to multiply to a positive, I know that I have to have an x and an x here, and they both have to have the same sign. They can't both be positive or they won't add to a negative, so I'm going to have two negative numbers. To multiply to positive 12, I can do 1 times 12. That's not going to give me 5. 2 and 6, that's not going to give me 5. 3 and 4, that's not going to give me 5. So I can tell that this will not factor anymore. And in fact, what I had up there was the factorization, the complete factorization of the 9x cubed minus 13x plus 20. This is where we're heading. Hopefully that'll give you some insight. Thanks.